So question 5 out of 11-2. The table below includes results from polygraph experiments conducted by these researchers. In each case, it was known if the subject lied or did not lie. So where the table indicates that the polygraph test was, so the table indicates where the polygraph test was correct. Use a 0.05 significance level to test the claim that whether a subject lies is independent of the polygraph test indication. Do the results suggest that polygraphs are effective in distinguishing between truth and lies? So as always, that sort of interpretation question we're going to save until we go ahead and figure out what our statistical conclusion is here. What true independence would look like here is the polygraph would have been, whatever its success rate was overall, it would have the same success rate whether the person was lying or not lying. And in terms of eyeballing it here, we are seeing about a 1 to 3 in that top row and about a 3.5 to 1 in the bottom row. So it is, you know, in terms of eyeball tests, they are looking different. Let's see how that plays out. So let's go and find our claim here. And when you go to name your variables, just to do enough is, you know, you don't have to give it huge names in that. So, and again, what's going to be nice about this is our null hypothesis is always that they're independent of each other. The alternate is they're not independent of each other. So I'm going to go ahead and call this polygraph result and truth are independent. And then pretty much the same except the word not below that. So polygraph result and truth or truth of subject, subject's veracity, all sorts of ways you can phrase this, are not independent. Or you could also just say are dependent. Once we do that, we'll do the R and the S. And here, the claim was independent, so we'll star the R there. Now, a quick aside is our author in this section always claims that they're independent. Go out in the real world, that doesn't necessarily have to be the claim, but every single question, he's always claiming that the two variables are independent of each other. So you're probably going to notice that you end up starring the R quite a bit in this section. So in part B, since this is always going to be a right tail test and we're going to be using StatDisk with these 4 numbers, I just combine parts B and C. So identify alpha and write our rule of rejection. So we reject null hypothesis if p-value less than or equal to 0.05. And at this point, we're ready to head on over to StatDisk. So 15, 32, 42, 9. So Mark, make sure I don't miscopy anything here. So 15, 42, or 15, 32? 42 and 9?
Hold on. It's pulling up the wrong screen for me on my side. I had this open and now it's gone. Give me 1 second, Gary.
Oh, that's it. I just went back really quick.
15, 42, 32, 9. You've got it.
Okay.
I thought I had it as a PDF, not as a Chrome tab.
We're going to go analysis, contingency tables. Make sure our significance level is what we want it to be. I put this table in columns 1 and 2, so that's what I'll check. Hit evaluate and hit plot. And what we see is our test statistic is definitely off in the tail there. So I'm going to copy this and take it back to OneNote. So now I can go ahead and say that our chi-squared is 25.571. And our p-value was pretty much zeros. Eventually, there's going to be a non-zero number there, but we only need to go out 4 to make our decision against our significance level. And zeros is definitely less than anything we're going to have for alpha, so we reject the null hypothesis. And when we reject the null hypothesis, we have the evidence. So we have sufficient evidence to sorry, it's acting up on me here, so let me see if that'll fix it. There we go. So remember that we starred the R, so it's going to be reject the claim that, and then our last bit is to just write the claim that whether a subject lies is independent of the polygraph test indication. So again, we're putting this together in 3 pieces. Always a good idea to go back and read it all the way through. We have sufficient evidence to reject the claim that whether a subject lies is independent of the polygraph test indication. So we're concluding that these are not independent. So, you know, how it's picking up whether or not they lied or didn't lie, it's not, you know, it's doing better than flipping a coin. It's, you know, it's definitely, it is distinguishing them. But when we get to our last question, do the results suggest that polygraphs are effective in distinguishing between truth and lies? Well, if we come back up and take a look at this, so here we had 57 lies, and it identified 42 of them, but it missed 15 of them. And in terms of if they did not lie, if they told the truth, it also picked up on that in the majority of the cases, but not all. There's too many false positives and false negatives happening here, and that's one of the reasons that polygraphs aren't admissible evidence in court. Overall, they're pretty good at this, but they're far from perfect, and it would have to be a lot closer to perfect in order for these things to do that. So it's kind of a mixed answer here. Yes. Yes, they are. And I think it's fair to say pretty good, but not good enough for court. Anything to add, Mark?
Yeah, the only thing I would add, and Gary did a good job doing that on this one. You have to be really careful with wording on contingency table tests on these 2x2 tables. Make sure what you are and you aren't saying, and particularly when it's a complicated situation like this one where it's the polygraph test indicated that the subject lied or indicated that they didn't lie, and we know if they lied in the background. Just take the time to kind of carefully read through the lead ups to these types of questions to make sure that your conclusions take you back and actually answer the question at hand. That's the most common mistake that I see. It's not the difficulty in running the 11-2 test, the chi-squared test for independence here. It's the conclusion that tends to trip people up in my experience.
Yeah, exactly, Mark. Because in terms of the StatDisk part of this, you know, we go over to StatDisk, we put in the table as we see it here, and as long as we use the right option in StatDisk contingency tables, we are going to get the right critical value, the right test statistic, the right p-value. But this is one of the reasons I don't focus on having you compute things by hand. We have the technology. Fine, use the technology. We need to be able to do this in the real world. We need to be able to go ahead, make the correct interpretation of our results here. That's really everything.